What's up, math scholars? We're going to do more with simplifying radicals today. So we'll start off with just reviewing, simplifying down cube roots, fourth roots, maybe a fifth root, but then we're going to throw variables into the mix. So that'll make life a little bit more interesting. So let's just refresh real quick how to do a cube root of 729. Or I think we did that one yesterday, didn't we? Did we do 375 yesterday? Yeah. Did we do 72 yesterday? No? All right, let's start with this one then. Try this all by yourself to see how it goes with your cubic. You're looking for groups of 3 if you're using the jail method. If you're not using the jail method, you're using a perfect cube method. So you need to factor down so that one of your factors is a perfect cube. And when you're done, you can look up and check how you did. So how did that one go? You can get a group of 3 2s. And they'll come out of jail, and the leader will get out, and the other 2 will be in the hole. And then these 2 3s stay inside. All right, we're going to go ahead and try a fourth root. What do you think that jail guard's up there saying? You need 4 guys to break for my jail. So kind of break it down so you can find 4 of the same number. Go ahead and try it by yourself. All right, did you end up finding your group of 4? They're all 3s. So I kind of break them out, and it's just kind of the way it works that the group leader is the only one that actually kind of survives the trip out of jail. The other ones just drop in a hole. And so there's the 3 that's out of jail, and this 2 over here is stuck inside. Okay? Yeah?
Okay, so like for my first 2, I did 6 and 27.
Let me go back. All right, the time has come to introduce variables to the whole jailbreak scene. This first example here is the square root of x cubed. So I'm just going to talk about what x cubed actually means. What x cubed actually means is x times x times x. And so it's almost like I made a factor tree by writing x times x times x, because I'm going to circle groups of 2 and have them run out of jail, just like I did with my numbers. So they're running out of jail, yay, they're out. 1 falls in the hole, just like always. So this guy gets out of jail. Oops, write my answer over here. This guy gets out of jail. And then this guy, sadly, couldn't find a friend, so he stays in jail. Does that answer make sense at all? It's very weird because they're variables. So the whole concept and the circling and the running from jail remains the same. Arjun's giving me a confused look. Was it confusing?
No.
You're okay? There are 3 x's, so you write them x, 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 circle 2 of them, break them out. Let's try 7 x's. Oh my. So it's the square root of 7 x's. 1, 2, 3, 4, 5, 6, 7. How many do I need in the group to break out of jail? 2. Absolutely. So that group's coming out of jail. 1 will fall in the hole. That group's running out of jail. He'll fall in the hole. That group's running out of jail. He will fall in the hole. So in our final solution, how many x's in total got out of jail? So you're going to write an x cubed out front of jail. And then this x never did get a friend, so he stays in. So that's great, but you're probably reaching the maximum amount of x's you would want to write out, huh? Would you ever want to have to write out like 10 of a variable? Or what if I gave you like y to the 50th? You probably wouldn't want to write that out, right? So I'm going to give you a way that you can figure out how many get out of jail by using long division, or just division in general. So there's a little baby 2 right here, right? What you can do is 10 divided by 2, and if it divides evenly, that's how many get out of jail. And if it doesn't divide evenly, you can just use long division, and the remainder that you get It will be how many remain in jail. So I'll show you that in a second. But what is 10 divided by 2? 5. So that just means that 5 Ys will be able to get out of jail. That'll be the answer. There's no remainder. No Ys will remain in. Actually, before we get to 2 variables, I want to go back and show you how I could have used division up here. So if I would do 3 divided by 2, let me show you with long division how that would work. 3 divided by 2. 3 divided by 2 would be 1, and 1 times 2 is 2. You subtract down. This is probably a blast from the past, long division. Did you ever learn that?
Yeah.
And then this guy's your remainder. So let me interpret this result. This means that up here in this first problem, 1x got out of jail, but 1x remained in jail. See it? 1 got out, 1 stayed in. Isn't that sweet? The same thing would have happened here. 7 divided by 2 would be 3, remainder 1. 3 get out, 1 remains in. Isn't that sweet? So they'll eventually get more than one variable and you'll do it more than once, but let's get a bigger, well, we'll do this one. We'll do that one with the G and the H's next. Alright, so when I do this problem, my advice to you would be write down the problem, of course, but then leave yourself like a big empty variable that you will fill with stuff. Big empty radical. I'm leaving space out front. These are the people that will get out of jail. And I'm leaving space in here. Those are people that are going to stay in jail. We're just going to use a series of divisions. What is 9 divided by 3? 3, with no remainder, right? So 3 G's will get out front, and none will remain inside. What is 8 divided by 3? That's a little bit harder. I'll do that with long division. 8 divided by 3 would be 2, and 2 times 3 is 6. You subtract straight down and you get 2. That's your remainder. So as far as what that means to us with our H's, is it means 2 H's get out of jail, but 2 H's remain in jail. 2 H's get out, 2 H's stay in.
You combine these.
Yeah, I just looked at that and I was like, oh, darn it. I didn't even notice those H's should have combined a long time ago. I can't believe they made the problem like that. These 2 H's should have been H to the 13th, so my apologies if you're using pen. If you're using pencil, you can just erase it. We should have actually done 13 divided by 3, huh? Sorry about that, everyone on the video. 13 divided by 3. 13 divided by 3 is 4, with the remainder of 1. So 4 H's get out, and 1 stays in. Sorry to backtrack on you. Does that make sense now, though? There was originally an 8 and a 5, and I could have combined them to get 13. I just didn't realize it until later on. Alright, we'll try this one, and I feel like then we'll get to the point where we'll try some word buddies. Alright, it's the 4th root. I'm going to make myself a big old empty 4th radical with some space out front for the people that get out. Let's start with my A's. What is 5 divided by 4? 5 divided by 4. And you can do it on paper if you need to. You can do it in your head if you can. 5 divided by 4 would be 1 with a remainder of 1. So 1A gets out, 1A stays in. What is 11 divided by 4? Probably 2 with a remainder of 3. So 2 B's get out and 3 B's remain in. And C's. 13 divided by 4. 13 divided by 4 is 12. Or sorry, 13 divided by 4 is 3 with a remainder of 1. So 3 C's get out and 1 remains in. That was a lot of variables to keep track of. Hopefully I didn't mess any of them up. I was having trouble concentrating. We're okay now? Alright, I'm calling 6 people up to the board to try this one. I did give them some advice, and that's use a factor tree to break the 125 down traditionally. Again, there's a jail guard of a 2 because it's invisible. And then they're just going to use the remainder trick for their Y's and their T's and their A's. Okay. Hello, people in the video. Our board buddies all did great, and here's the final answer they got. So you can go ahead and check if you got that answer. And you can put that 2 there if you want to, but it's optional. Alright, here's our next board buddies problem. So I get 6 more people. Alright, all my board buddies did awesome. This is the answer that they all seem to have. 2x to the 3rd, y to the 9th, z to the 11th, and then in jail was the 17th and x. Okay. Alright, I'm okay with calling it a day here and just letting you work on your homework. Sound good? Some of you already started. It's the back of last night's homework. Thanks for watching our video and have a super happy weekend.